Electricity has been a vital necessity for many years, and yet, today, according to the United Nations, there are near 800 million people around the world without access to this service. Ironically, most of the places where the price of electricity people live are high solar radiation zones where solar panels work ideally. That kind of technology, despite being the most popular form of clean energy used, isn't available for everyone because the high cost that solar panels still have make them difficult to afford for the people around the world that need them the most. Along with access, there are other difficulties like the great space and infrastructure required for their installation and proper usage that lead into solar energy not being worldwide used even when it could positively contribute in solving other severe problems like poverty, education, hunger, health, safety, and many more. That's why we've developed a solution: a hexagonal chlorine-based photovoltaic cell, the Solar Mesh. These new-shaped photovoltaic cells can transform the solar energy into electric energy, being exposed to the sunlight in a more efficient way thanks to the new design, which allows the device to be flexible and adopt multiple forms for an optimal exposure. The design is beautifully thought to create forms never seen before in a solar panel, that deliberately makes it flexible and adaptable to several shapes, making the device space efficient, versatile, and easy to install since it doesn't require nor a specialized technician nor a heavy structure or an external support. Since the photovoltaic cells are built with different, cheaper, and easier to find materials than the ones currently used in conventional solar panels, the manufacturing process is cheaper than the one used in the most competitive panels. The solar mesh is fabricated with a hexagonal aluminum bed, a specific geometry to create a netting system that allows it to be installed in any kind of surface, where the coverage area can be greatly increased thanks to the modular design capable of adding as many cells as needed without making a huge investment from scratch. This means that the solution could be scaled according to the user possibilities and requirements, without being conditioned to a sole supplier or further funding. The chloride zinc used in this cell is a material with a similar crystalline structure as silica and semiconductors like gallium nitride. This compound can be doped with many other elements to gain semiconductor properties, being able to generate electricity when exposed to the sunlight. The process for synthesizing this compound and to generate the photovoltaic cells needed a chemical deposition equipment capable of controlling multiple variables such as time, temperature, speed, and distance. Because of this, we had to design and build a spray pyrolysis machine using 3D printing and a Python-based software, through a PID model for the hotbed, motor drivers for the flow velocity control and atomizers. Being able to fabricate a customized and low-cost spray pyrolysis machine. This allows to produce thin layers of the chemicals required for the solar cells, leading the cells to reach their optimal functioning. The solar mesh solution allows to produce multiple types of devices, such as light posts, adaptable nets for different types of roofs, multiple 3D forms besides a panel, and portable devices. Imagine wearing solar technology like a bracelet, or to enlighten the schools of emergent communities, despite space restrictions, being in remote locations, or phone-related issues. With the solar mesh solution, everyone around the world will have access to solar energy.